Assalamualaikum. Welcome to this video on timer mode 1 programming for 8051 microcontroller. In this session, I'll try to explain the concept of timers, how they are configured, and how we can use timer mode 1 for creating time delays in performing other tasks in embedded system. So what is timer? A timer in a microcontroller based system is a tool that can count the number of clock pulses over time. It can either count internal pulses from the system clock or external pulses fed through specific pins on the microcontroller. In the 8051 microcontroller, timers are very essential for operations such as generating delays, measuring time intervals, and counting events. 8051 microcontroller has two 16-bit timers. They are timer 0 and timer 1, both of which can be used in different modes to perform various tasks. In this lecture, we will focus on timer mode 1, a 16-bit mode used to generate precise time delays. So here, these are the two registers that are timer mode 0 and timer mode 1. As we are focusing on timer mode 1, it has total 16 bit of registers, the lower 6 bit and the higher 6 bit. The higher 6 bit and lower 6 bit are almost similar, where the both time 0 call is the mode register to get the result. Here, get pulse is the getting control when is set. The timer counter is enabled when the INT-X pin is high, TRX control pin is set, then gate is on. When CT counter timer, when it is selected, then counter is on. When it is cleared, then timer is on. The lower two bit are mode 0 and mode 1. This is how we can select the mode. For mode 0, we have to just add mode 00 for 1, 0, 1, 2, 1, 0 and 3, 1, 1. For mode 0, it is called prescaler, and for mode 1, it is called cascaded mode, as it has both timer high and timer low associated with it. The timer mode 0 and 1 are both accessed by T-mode register. T-mode register is a 8-bit register, so total 16-bit is accessed by T-mode register 8-bit and 8-bit. For the T-mode 8-bit register, it is also accessed by upper 4-bit, which is called timer 1, and lower 4-bit, which is called timer 0. So for timer 0 and timer 1, we have to access it differently. Here it is how we can do it. If you want to select timer mode 1, then we can use this code, move TMOD. Here, the first 4 bit are 0. That means timer mode 1 is 0 and timer 0 is selected. But if we want to select timer 1, then we have to put 1. Here is 1, 0, and you can see it here that is timer 1 is selected. And for mode 2 timer 0, we have to select this one. So the lower 4 bits are mode 0 timer 1 and the upper 4 bits are mode 2 timer 0. And for frequency of the timer, it is called the rate at which the timer increments the counts. If CT, it means counter timer is 0, it derives from the crystal oscillator frequency. 8051 timers use total 1 by 12 crystal oscillator frequency that we have seen previously. After each 12 clock pulse, timer increments that we will see soon enough. If it is selected 1, that means it will count external pulses, not the internal one. And for timer, it always use failing edge, that means high to low, like this. Here it is now T-con register. T-con register controls start, stop of timer. Also indicate overflow using flags. So if TRX is 1, that means timer start counting. TRX is 0, then timer stops counting. And timer always counts up to FFFH from 0000H, as it is a 16-bit mode. For delay calculation, we have to use this formula. The crystal oscillator frequency, we have to take it from here. And this is the maximum that can go, and this is the one that we will put as timer low and timer high. Steps to generate a timer delay using timer mode 1. The first one is load the T mode value register indicating which timer, timer 0 or timer 1 is to be used and which timer mode is selected. Then load register TL and T high initial counts values as the value TL and TH you will put, it will count up to FFFFH. Start using set BTRX as we have seen, we have to put it like this way. So first we will set TRX as set. Keep monitoring the timer flag TFX with the JNB TFX target. We will see this in the code section. Stop the timer using CLR TRX, which means clear TRX. When it is cleared, the timer will stop. Clear and the TFX flags for the next round. If we clear TFX flag, it will go for the next round. Here is the code. First, we use move TMOD 01H. It means timer 0, mode 1 is selected. The first 4 bits are like this 0000 and 1 means 0001. That means timer 1, timer 0 and mode 1 is selected. As this is are all 0. Then we have to put the timer low value and timer high value. We have put it FFF and F2H here. Here is a 0 in both cases because if we just put like this F2H, this is the invalid case. So we have to put a 0 before it. This is the total count value or the total initial value. So here it is, you can see that the initial value is FFF2 and we will count up to FFFH. So it will like FFF2, F3, F4, F5, F6, FA, FB, FC up to FF. So the total count will be here and we can use this formula for the total count duration. Here is another code. It explains that here we have total time delay is FFF2 up to FFFH. But if we want more delay, then we can just use 0000H. Then it will count 0000H up to FFFH. Then the count and the delay will be larger. As the question suggested, it is for larger time delay possible. Here is the formula for total delay. The maximum minus the initial that we have given plus 1. This plus 1 is because here we can see that the maximum is FFFH, but it will go to next 0008 to make TF is equal to 1. So we have the maximum minus initial plus 1. This will be the total delay, both frequency and time. That will be the total delay answer. If we consider 2 megahertz crystal oscillator, then the total time will be in every duration will be 1 microsecond. Like for the first example here, we use the initial as FFF2 and here is the total delay calculation. The maximum value FFFH minus initial value FFF2 plus 1 into as crystal oscillator is 12 megahertz, the time will be 1 microsecond. So the total answer will be 40 microsecond. And for the next question, the largest time delay possible. Here we took the initial as 0000H and the maximum is always FFH. So here the maximum value minus initial value plus 1 in the time delay. So the answer will be this microsecond. So we can see that this is the total time needed to increase the timer by a single digit. It means the timer is increasing and 1 microsecond as 12 megahertz crystal oscillator is used. This time is needed to increase 1 digit to go to the next count. Like this up to maximum, then 0. So if we extend this again, at first we use move TMOD 01H. It is used for to select mode 1 of timer 0. Then we use move TL0 0 FH and TH00 FH. This is timer low, timer high. Here we can see that these are the timer low and timer high values. Here, these four are timer low, these four are timer high. Then we use CPLP 1.5, it means complement port 1.5. As the question said, create a square wave of 50% duty cycle. Each portion will be equal high and low. So the figure we can see here that in this waveform square wave, 50% duty cycles means 50% time will be low and 50% time will be high. So at each relay, the delay time of low and high pulse will be same. So we use complement port 1.5. It means the port will be complemented first high, then if you complement it will be low like 1 and 0. Then we said that equal delay, it will call the delay subroutine. So from here we will go to the subroutine. At the subroutine, we put set the TR0. First, TR0 means timer 0 will start. As TR0, timer 0 is set. It means it has put 1 or maximum. That means timer is started. It is on. Then there is a code again JNB TF0 again. It will loop forever here. It means jump is not bit. That means if TF0 is 0, then it is not bit 1 and it will continue to jump again and again. When it become 1, then it will go to the next line. The next line is clear TR0 and clear TF0. We use clear to clear timer and clear overflow flag. This will clear the timer to 0 to start again and this will clear the overflow flag. Then return, we will go back here, then short jump here, it will go here again. Again the initial value again complemented. So for the first portion, port 1.5, the if we take high for the first time and it has counted up to this value which is 14 microsecond, then it will be complemented 1 to 0. It will count for another 14 seconds, then it will be again complemented to high and count for another 14 microsecond. This way the cycle will just go run on again and again with 50% duty cycle high and 50% duty cycle low. So we are achieving this delay with delay subroutine. Using this delay subroutine, the continuous high to low pulse are occurring because of complement command. Then if we want more delay, what can we do? We can use loop. Mm, if overheat is comparable to total delay, then we should consider like 28 is comparable to 14. It means that when we were always counting the subroutines value. The subroutines value were very large, like 65535 microsecond, but we were not counting the other cycles. These cycles were smaller, like two cycle. So compared to 65536 to 28, we do not need to count 28. We can only count this value for the total delay time. This is another note about it. First, we use clear port 2.3. It means the port is now set to 0. Then we put the initial value 00018. So it will count from F to 00018 plus 1. Run the timer. Timer will be 1 microsecond if it had 12 megahertz crystal oscillator, but it is here 11.05 90 megahertz, so we have to use 1.085 microsecond. And it is the exact similar code like previous. First, port 2.3 is clear. Then we have port set port 2.3. That means first it is 0 for port 2.3 and it will count up to this timer value or delay. Then it will become set, which is mean 1. So it is another square word which will count the same time value. Now we want to make larger time delay. For larger time delay, we need to use loop. So how can we use loop? It is the exact same code like previously. First, we'll select timer and mode. Then we have put move R3 200. It means R3 register has 200 value. Then, like previously, we put TL1 and TH1. That means in timer 1, this is the total initial value. So total delay will be the maximum value FFH minus the initial value we have put it, which is 01088 plus 1 multiplied by 1 microsecond as 12 megahertz crystal oscillator is used. Now, this delay time will be uh, is inside a loop. So from the code, we can see that R3 is 200, and we have put here again. Then here's a loop like if jump if not be TF1. That means the total similar code like previous up to this. Then here is another line that is set decrease and jump if not 0 R3 again. It means this whole portion will is inside this loop. This loop will continue 200 times until R3 is 0. So it said decrease and jump if not 0 R3. That means first the R3 value was 200, then next it will become 199 and up to 0. So up to this time 200 times this loop will work, and the total time will delay time will be the previous calculation multiplied by 200. So the delay will become larger. Previously we see that the maximum delay can be get when the initial value was 0008, but no more than that, which can be 65536 microsecond. But if we want larger time delay, then we can use loop like this. And this is up to mode 1, but let's see some more. For mode 0, it is a 13-bit timer, and for mode 2, it is a 8-bit value. Mode 2 is 8-bit. Previously, mode 1 was 16-bit. Mode 0 is 13-bit, but mode 2 is 8-bit. So it can count maximum up to FFFFH, not FFH. So it counts up to low value. So when we write the code, we need to give initial value in both T high and T low, like previous. The code is exactly like previous. First we selected mode and the timer. Then we put timer high and timer low value. Then to start the timer, we have to put it set the tier 1. Then we have to clear the timer to stop and to stop the overflow also. And it is also the code for a square wave. First set the tier 1, it means the square wave is 1 or maximum. Next complement port 1, it means in the next portion the code will be complemented and become 0. Then it will become again 1, again 0, and it will go on. These are the same map. These are the formula to count the delay. CT value 1. It means the timer is not on, the counter will work here. For the counter, we will need to use port T3.4 and port 3.5. Previously, we used port 1.3 or 2.3, now 3.4 and 3.5. And previously it was low to high edge, and now it is high to low edge, which is the falling edge. Here we can use the code like this: the T mode is equal to 0, 1, 1, 0, 0, 0, 0, 0, which is similar to 0, 3, 0, or just 3, 0. So this is timer 1 mode 1. Thank you.